In this module, we're going to talk about S3 encryption. So first we'll talk about what is data protection or S3 encryption and why is it used and what are the different ways to encrypt your data. And then we'll go over both server-side encryption and client-side encryption and all the different ways that you can perform encryption on S3, and there are quite a few. And then we'll finish out with typical questions that you'll find on the exam in this area. All right, so what is data protection or S3 encryption? So it's used to protect your data in transit as it travels to and from S3 and at rest while it is stored on disks in S3 data centers. And we show a simple diagram here showing how your Lambda function or S3 application or any application that you're using is using encrypted data. It uses a data key and an encrypted data key to interface with KMS, maybe, depending on the scenario, to unencrypt your data or encrypt it, depending on whether you're sending it to or receiving it from S3. And you protect your data in transit with secure socket layer, transport layer security or SSL/TLS, or client-side encryption. And we'll go into client-side encryption in a minute. And there are two types of data protection at rest with S3, of course. There's server-side encryption, and here we'll cover SSE S3, SSE KMS, and SSE C, those three types of server-side encryption with S3. And you'll understand what all those acronyms mean in a minute. Then we'll talk about client-side encryption. But before we go into the server-side encryption and client-side encryption, let's go over a few basic primary things you need to know about S3 encryption. So when thinking about S3 and encryption, you have to remember that you don't encrypt S3 or encrypt an entire S3 bucket. What you do is you take advantage of S3 to encrypt your data at the object level as it writes to the disks in an AWS data center and decrypt your data when you retrieve it. And so S3 encrypts your data at the object level as it writes it to disks in its data centers and decrypts it when you retrieve it. And S3 uses a concept called envelope encryption to protect your data at rest. So each object is encrypted with a unique key that employs strong multi-factor encryption. And as an additional safeguard, S3 encrypts the key itself with a master key. And also, S3 server-side encryption uses one of the strongest block ciphers available, 256-bit Advanced Encryption Standard, or AES 256. You may see that on the exam, to encrypt your data. All right, so now let's go into our server-side encryption. First up, server-side encryption with S3 managed keys, or SSE S3. So with SSE S3, each object is encrypted with a unique key. And to additionally safeguard the data, this technique encrypts the key itself with a master key that is regularly rotated. And it uses the AES 256 block cipher to encrypt the data. And one of the things you'll need to know for the exam, there are questions on this. When server-side encryption is required for all objects in a bucket, you'll use a bucket policy. And then, for example, you'll use a bucket policy that denies permissions to upload an object unless the request includes the XAMZ server-side encryption header to request server-side encryption. So this you will see on the exam, this XAMZ server-side encryption header concept. And I show an example here of the way the header looks. We have a put of an object to a bucket, and the content type is text. You see the content length, we see the author, and we see that in the header we have the XAMZ server-side encryption, AES 256. All right, so now let's go over the flow of SSE S3 when it comes to encrypting data on S3. So it works like this. So you have a client that has a data file it wants to send to S3. So the first step, the client selects the file to upload to S3 and indicates that it's going to use SSE S3 to encrypt the object. So then in step 2, S3 takes control of the object and encrypts it with a plain text data key that is generated by S3. S3 then takes the object and encrypts it with a plain text data key that's generated by S3 using an encryption algorithm, and the result is an encrypted version of the object. And that object is then stored within your chosen S3 bucket. And then in step 3, the plain text data key that was used to encrypt the object is encrypted with an S3 master key using an encryption algorithm. Then the result is an encrypted version of the key. So we have an encryption algorithm that encrypts the file itself using a plain text S3 data key, and then we have the key itself, the data key itself, being encrypted using an encryption algorithm using the S3 master key. And then finally, the plain text S3 data key is removed because we now have an encrypted S3 data key that we can use. All right, let's move on to SSE KMS. So, server-side encryption with AWS KMS managed keys, or SSE KMS. So this technique, server-side encryption with customer master keys, stored in AWS Key Managed Service, or SSE KMS, that's a long name, is similar to SSE S3 with additional benefits. First benefit, we have separate permissions when using a CMK that provides added protection against unauthorized access of your objects in S3. And S3 provides an audit trail that shows who used the CMK and when they used it. And when using this technique, you can create and manage your own customer master keys, or you can have AWS manage your CMKs, which is called AWS Managed CMKs. And those managed CMKs by AWS are unique to your account, the service you're using, and the region you're working in. Okay, so let's talk about how this technique works. So it's a 5-step process. In the first step, the client selects their object or file again to upload to S3 and indicates that they're going to use the SSE KMS encryption technique with an associated customer master key, or CMK. And then in step 2, S3 requests data keys from KMS to allow S3 to encrypt the data submitted by the client. And then in step 3, using the customer master key selected during step 1, the Key Management Service, or KMS, generates 2 data keys, a plain text data key and an encrypted version of that plain text data key. And then in step 4, KMS sends both of those keys, the plain text data key and the encrypted data key, back to S3, and this will allow S3 to perform the encryption needed, which happens in step 5, where S3 then encrypts the object using the plain text S3 data key and encryption algorithm. It generates the encrypted file and an encrypted S3 data key, which are stored in S3, and then the plain text S3 data key is removed once again. So that's how AWS KMS Managed Keys SSE KMS works. Last, let's talk about server-side encryption with customer-provided keys, or SSEC. So with this technique, you, the customer, manage the encryption keys. And when S3 writes your data or your files to disk, S3 manages the encryption for you. So you manage the keys, S3 manages the encryption. And when you access your files, S3 decrypts the data for you. But S3 does not store your encryption key. But S3 stores a randomly salted HMAC value of your encryption key to validate your future requests. But you can't use the salted HMAC value to derive the value of the encryption key, or even to decrypt the contents of the encrypted object. So if you lose the encryption key, you lose the data. You'll never be able to unencrypt the data. All right, let's quickly talk about the 2 steps that are used when you work with customer provided keys, or SSEC. So the first step, the client uploads a file or an object to S3 and the client sends along with that object the customer provided key, and you must use an HTTPS connection to do this, of course. It has to be secure because you're sending your key with your data. And if you try to use SSEC without an HTTPS connection, then the upload will fail and will be rejected because you need to encrypt the communication channel because you're sending your key along with your data. All right, and then in step 2, S3 takes the customer provided key and the object, and it performs encryption of the object using an encryption algorithm. And in addition, S3 will generate a salted HMAC value of the customer key, and this will enable validation of future access requests. And the HMAC key and the encrypted file are stored on S3, and the customer key is removed. So that's how SSEC works. So there we are. We've covered all of the server-side encryption techniques. Now let's talk about the client-side encryption techniques. So there are a few aspects of this to go over. So first, S3 client-side encryption, CMK stored in KMS. So with this technique, you encrypt data before sending it to S3, of course, and there are two options. Use a customer master key, or CMK, stored in KMS. This is the first option we're going to go over here. In the next slide, we'll go over the second option. So when uploading an object, using the customer master key ID, the client, the sender, first sends a request to KMS for a new symmetric key that it will use to encrypt the data object. And then KMS returns a plain text key version used to encrypt the data and a cipher blob key version that is sent with the data as metadata. So that's how you upload an object, and then you get back your key from KMS. And then when downloading an object in this CMK stored on KMS technique, the client downloads the encrypted object from S3 together with the cipher blob version of the data key that is stored as metadata. So this metadata is flowing back and forth between the client and KMS. The client then sends the cipher blob to KMS to get the plain text version of the data key to use for decrypting the object data. All right, so that's client-side encryption using a customer master key stored in KMS. The second option, use a master key stored with your application. So here, when uploading an object, you provide a client-side master key to the S3 encryption client, which uses that master key only to encrypt the data encryption key that it generates randomly. And then the S3 encryption client generates a one-time use symmetric key, which is also known as a data encryption key or a data key, locally. It uses the data key to encrypt the data of a single S3 object. The S3 client generates a separate data key for each object. So now here we're using a key for every object. S3 client encrypts the data encryption key using the master key that you provide as part of the request or the sending of the object. And then when downloading an object using this master key stored with your application, using the object's metadata, the S3 client determines which master key to use to decrypt the data key, then uses that master key to decrypt the data key, and then uses the data key to decrypt the object and sends it back to you. So it sounds very complicated, and there is a lot here, but let's talk about what you'll typically see on the exam in this area. So typical exam questions for S3 encryption. First, you'll find questions like this. A company does not want to spend time managing and rotating keys, but wants to control the keys that they use for encryption. In this case, you're going to use server-side encryption with AWS KMS managed keys or SSE KMS. Another typical question, a company plans to store sensitive user data on S3, and they have a mandate to encrypt the data before sending it to S3. And in this case, of course, you're going to want to use client-side encryption, and most of the time you're going to use client-side encryption with a master key stored in AWS KMS. So 9 times out of 10, if you have client-side encryption on the exam, the answer is going to be client-side encryption with a master key stored in KMS. Another one, ensure that all objects uploaded to an S3 bucket are encrypted. We went over this in a previous slide. You want to update your bucket policy to deny the put of an object if the header of that put does not have the XAMZ server-side encryption header set on it. And then one more, you want to manage your own customer managed CMK or use an AWS managed CMK. So when would you want to manage your own customer master key or have AWS manage your customer master key? So for this type of question, when the question indicates that the client or the customer wants to have complete control over rotating their keys and managing their keys, you're going to want to use, of course, your own customer managed CMK. Other questions will say that the client doesn't want to spend the time or the energy managing their own keys. Then, of course, you're going to want to select the AWS managed customer master key. Okay, let's jump over into the AWS console to do a quick demo before we close out this module. Okay, so here we are in the AWS console in the S3 part of the console, and I have one of my buckets listed here. So if we go into our bucket, and if we go into the properties for the bucket, and we scroll down to default encryption, so we can have S3 automatically encrypt new objects stored in this bucket. We can't encrypt the entire bucket, but we can set up a default setting that allows us to automatically encrypt objects as they are stored in this bucket. And now, of course, we have to choose our encryption key type. We can use SSE S3, or we can use SSE KMS. And it says also that we can use SSEC, but to do that, we need to upload an object with the customer provided key. And the only way to do that is through the CLI, the SDK, or a REST API, because the console doesn't give you the option to pass a customer provided key through the console. You need to do it in any of these programmatic interfaces. All right, so say we want to use an S3 key. That is a key that Amazon S3 creates, manages, and uses for you. Or we can choose Key Management Service Key, SSE KMS, which is an encryption key protected by AWS Key Management Service. And as you remember, there are two types. First, we can use an AWS managed key, or we can choose from one of our keys, and I can pick a key that I have. I would first have to create one, and then it would be available here. Or we can enter a KMS key ARN, or we could create a new key. So the two choices again are AWS managed key or one that you manage, a customer managed key, as you remember from the lecture. We can also reduce encryption costs by decreasing calls to KMS for new objects in the bucket, and to do this, we specify a bucket key setting for an object. And we need to use the CLI, the SDK, or an S3 REST API to do that. We could do that or not. All right, so those are the settings at the default encryption level for the bucket. And one more thing, let's take a look at one of the objects or one of the folders prefixes in the bucket. Let's take a look at a prefix. So if we select the prefix, we can choose actions and we can edit server-side encryption. And once again, we have our settings of we want to enable it, and then we can pick between an S3 key, SSE S3, or a KMS key, SSE KMS, and we have the same choices again. AWS managed key, customer managed key, we can enter it by ARN, and so on. Now, one of the things to remember, if you set this, this action creates a copy of the object with the updated settings and a new last modified date, because this object is already in the bucket or this prefix and all the objects in it are already in the bucket. This action applies to all objects within the specified folder or prefix, objects added to these folders, prefixes, while the action is in progress might be affected. But once the action is complete, any object that is loaded into this prefix will get these KMS encryption settings. Objects copied with customer-provided encryption keys, SSEC, will fail to be copied using the S3 console. You can't do it. So you have to copy them using the CLI, the SDK, or one of the REST APIs, as I said. So that's a prefix. And then if we want to look at an actual object, let's pick this one. We'll do actions, edit server-side encryption. We can enable, and we can choose SSE key and KMS key again. Same choices for KMS key, AWS managed, customer managed, and so on. And what this setting says here is this action creates a copy of the object with updated settings and a new last modified date, because this object is already in the bucket. Any objects copied with customer provided keys, in other words SSEC, once again, will fail to be copied using the S3 console. You can't do it. So you need to use the CLI, SDK, or REST API. Now the typical way to encrypt objects as you put them into your S3 bucket is to not do it after the fact, as I am showing here, but it is to do it as you move the object into the bucket. And that is done using your programmatic interfaces like the CLI or the S3 APIs or the other programmatic techniques. But let's add an object to our bucket and set encryption on it as we add it to show you how it's typically done using the console. So let's put one of our pictures here. Maybe we can put that. And now I want to set its properties. And I want to go to its server-side encryption settings. So I want to use an encryption key. And here we are again, we have the choices. S3 key or AWS key managed service key, KMS key. And if I choose KMS, I can use an AWS managed key, or I can use one of my own keys, or I can enter an ARN. So here they are. These are the encryption settings that we've been discussing in this module, shown to you in action as you add an object to your bucket. Now this is through the console, but of course we can also do these through the CLI, the SDK, or an S3 REST API. All right, so I'm going to cancel this. Great. So that is a demo of how you set encryption on existing objects or prefixes, or set a default setting for the entire bucket, or how you set those settings as you move an object into the bucket. I showed you the console, but like I said, can be done through the CLI, the SDK, or a REST API. Okay, so just remember the 3 types of server-side encryption and the 2 types of client-side encryption, and when you would use each. Review the material in this module a few times. It's a lot and it can seem complicated, but if you concentrate on the basic differences between the 3 server-side and the 2 client-side, you'll have enough knowledge to get through the questions in this area on the exam.
For more details, check the link in the description. Learn with Whizlabs. Success certified.